Similarly to the last question with the headwind and the tailwind helping us out, we also want to talk about current. So this says a canoe is can paddle 12 kilometers upstream and 12 kilometers back downstream in the same amount of time that she can paddle 25 kilometers in still water. If the rate of the current is 2 kilometers per hour, what is the rate in still water? So think about in the last question, we had to find the tailwind. We had to find how much the wind was. This one, I'm giving you the current. The current is what helps you or hurts you when you're in water. So if you could think about when you're in the ocean, sometimes you hear about the current or the undertow pulling you in or pulling you out. It's similar to that. This says, so if we make our chart here, I'm talking, let's see, canoes can paddle. We're talking about upstream, and we're talking about downstream. And for this one, we're also going to mention the still water in our chart. And if you have trouble with this, upstream is when you're going against the current, downstream is with the current. So when you're going downstream, you're going to go faster because the current's helping you out. Rate, time, distance. All right, let's plug everything in. Canoes can paddle 12 kilometers upstream. So my distance is 12 for both of these. In the same amount of time that she can paddle 25 kilometers in still water. So that means if you take the upstream and downstream and add them up, it should equal how long it took her to paddle in the still water. So these two trips added up will equal the still water trip. Now they also tell us that there's a current. It says we don't know the rate. We don't know the rate of the water, or her in still water. So I'm going to say this is just her rate, her R. But when we're going upstream, the current, which I said is 2 kilometers per hour, is going to slow us down. So this is going to be your rate minus 2. When you're going downstream, it's going to increase your speed because the current's working with you rather than against you like upstream. And now we're going to set up our equation based on the time because that's our missing variable. So we're going to do time equals distance over rate. So it's 12 over r minus 2. 12 over r plus 2 equals 25 over r. Now remember, we said there's an important sentence here that tells us how to set it up. Canoes can paddle 12 kilometers per hour, or 12 kilometers upstream and 12 kilometers back downstream in the same amount of time. That is the important part here. In the same amount of time that she can paddle 25 kilometers in still water. So my equation I'm going to say is 12 over r minus 2 plus 12 over r plus 2 equals 25 over r. And to solve this one, it's going to require a little bit more algebra because your GCF, or your LCD, is r plus 2, r minus 2, and an r. So everything's going to need to get that. So we're going to put that in the top for each one. R plus 2, r minus 2. R plus 2, r minus 2. R plus 2, r minus 2. And then we can cancel out. Here the r minus 2's go. Here the r plus 2's go. Here the r's go. So I have 12r times r plus 2 plus 12r times r minus 2 equals, and I'm going to FOIL this out now, r squared minus 4. We can distribute 12r squared plus 24 plus 12r squared minus 24 equals r squared minus 4. Combine your like terms. You guys should be able to do this pretty quickly at this point. When you combine your like terms, we get 24r squared plus, let's see, actually your 24 and your 24 here cancel. So you just get 24r squared. And then we have equals r squared minus 4. I am going to, hang on. Oh, I'm sorry. I forgot this 25 out front. Should be 25. I apologize, guys. Should be 25 times r squared minus 4, which is 25r squared minus 100. And now we can subtract over, so this should be a 25r squared. Subtract over 24r squared, so we have r squared minus 100 equals 0. R equals 10 and negative 10 if you add, or if you factor in and solve it. Now remember, you can never have a negative rate, so my negative's out. So my rate, which was just my R, the rate in the still water is actually what we were trying to figure out for this question. So my rate in the still water, which is just R, we're going to say is 10 kilometers per hour. Your rate in, if it asks your rate going upstream will be 8 kilometers per hour, going downstream will be 12 kilometers per hour.